Have a look at this tree structure representation of the number system. All the numbers can be classified as real numbers or imaginary numbers. The real number can be further subclassified as rational number or irrational number. The integer, whole numbers and the natural number are the subset of rational number, and prime numbers and composite numbers are the subset of natural numbers. In this video, we are going to learn about each of these number types and how to remember these number types. This is going to be a most interesting part. Friends, watch full video for complete understanding and subscribe the. Let's begin with the natural numbers. So natural numbers are the counting numbers which begins with 1 and increment to the infinity, like 1, 2, 3, 4, 5 and so on till infinity. All are the natural numbers, and natural numbers do not have a decimal point. Now the most important part, how you are going to remember the natural numbers. So as I said, these numbers are used for counting. So what you can count is basically a natural number, as easy as it looks. I can count 3 strawberries, hence 3 is a natural number. I can count 4 strawberries, hence 4 is a natural number. However, I cannot count 0 strawberries or 1.5 strawberries, hence 0, 1.5. These are not the natural numbers. Natural numbers are denoted by capital letter N, which is a set of numbers from 1 to infinity. On number scale, you can see all these numbers from 1 to infinity. These are all natural numbers. Let's move on to whole numbers. So if we add 0 to natural numbers, it becomes whole number. So I have my natural number 1, 2, 3, 4, so on. If I add 0, it will become my whole number. So you can say that every natural number is a whole number. So whole numbers are represented by letter W, and which is a set of number which starts with 0 and it increments by 1 till infinity. Now the question is how you are going to remember the whole number. Look at this word whole. So this big O is how you are going to remember. So this O means 0, what you are going to add to natural number, so it will become whole number. The 0 is a complete number, but it does not exist naturally. That's why we cannot have 0 in my natural number. Now once I add 0 to natural number, my number system becomes complete. That's why we call it as a whole number, and that's the need of the whole number. So on the number scale, you can see whole numbers we can represent from 0 to infinity. Let's understand the integers now. An integer is a whole number that can be positive, negative or 0, which means the set of integer has all natural numbers 1, 2, 3, 4. These are my natural numbers. It has 0 and it has all natural number with the negative sign, like -1, -2, -3 and so on. All integers are represented by letter Z, so which is a set of 0, all natural numbers and all natural number with negative sign. Now the question is, what is the need of integers? We know why do have the numbers from 0 to infinity, but why do we have numbers in negative? Let's first understand that. Let's say you have $100 and you give it to your friend. Your friend return you $50 only. Now how much balance do you have? -$50. We know there is no such note available in the market which amounts to -$50. However, this negative sign indicates that you are in a loss. That's the reason these negative values are required. Now all natural numbers and whole numbers are basically integers. So on number scale, we can represent the integers like this. So all negative natural number, positive natural number and 0. And we can see the W and N, that is whole number and natural numbers, are basically subset of integers. Let's understand the prime numbers now. So prime numbers are the natural numbers greater than 1 and it has only 2 factors, that is 1 and the number itself. So P, let's say, is a prime number, then it will have only 2 factors, 1 and the number itself, that is P. For example, number 7 is a prime number because it has only two factors, that is 1 or 7. It can be divisible by either 1 or 7. However, number 4 cannot be prime because it has one factor as 1, 4, and apart from 1 and 4 it has one more factor, that is 2. It can be divided by 2. Hence 4 is not prime, whereas number 7 is a prime number. Now the most interesting part, how you are going to remember the prime number. So just have a look at this word prime. So the prime means primary or important, or which is not secondary, which means you cannot form this number using any secondary number. That's the reason it is called as prime number. Some of the prime numbers are 2, 5, 7, 11, 13, 17 and so on. Now the question is number 2 a prime number? So answer to this question is yes. Number 2 is a prime number because it is divisible by 1 as well as number 2, that is itself. That's the reason number 2 is prime. In fact, number 2 is the only number which is prime as well as even. Now what about number 1? So number 1, please note down, it is not a prime number even though it is divisible by 1 as well as itself, because number 1 has a special treatment which anyways I'm going to explain in a separate video. So you have to remember number 1 is not a prime number. Begin with the composite numbers now. A composite number is a natural number which has more than 2 factors. Each number has 2 factors, that is 1 and the number itself. Apart from that, if it is divisible by some other number x, then it's a composite number. This definition is exactly opposite of the prime number. For example, number 6, it's a composite number because apart from 1 and 6, it can be divisible by 2 as well as 3. That's the reason number 6 is composite number. Number 10 is a composite number because it can be divisible by 1 and 10, and apart from that it can be divisible by 2 and 5. That's the reason 10 is composite number. However, number 11 is not a composite number because it can be divisible by 1 and 11 only. It has only 2 factors. Now the question is how you are going to remember the composite numbers. So it is as simple. So let's understand the literal meaning of word composite. So the composite word says made up of several elements. Hence the composite numbers are made up of several numbers. It is as easy to remember. That's the reason it is called as composite number. Some of the composite numbers are 4, 6, 8, 9, 12 and so on. Now let's understand some important facts about the composite number. The first composite number in the series is 4. All even number except 2 are composite numbers, as all even numbers are divisible by 2. Number 1 is not composite or non-prime. Please remember this fact. Number 1 is a special number. Let's move on to rational numbers. A rational number is a number which can be represented in form of fraction, that is in form of p by q, where p and q both are integers and q is not equal to 0. So all the numbers which we can represent in form of fraction, that is 3 by 5, 1 by 2, 6 by 7, 5 by 4 and so on, are rational number. All rational numbers are represented by capital letter Q. Now you might ask me question whether all the integers, that is -2, -1, 0, 1, 2, 3 are all these rational number. So answer to this question is yes, all these numbers are rational number. The reason is each number can be represented like this, -2 by 1, -1 by 1. So any number divided by 1, you will get answer as the same number. Hence all these numbers are rational numbers. Now coming to the most important part, how you are going to remember the rational numbers. So just have a look at this word rational. It has ratio into it. So the ratio means fraction. So which means any number which can be represented in form of ratio or fraction is a rational number. Let's understand the type of rational numbers. So there are two types of rational number. Number one is terminating rational numbers and number two is non-terminating and recurring rational numbers. For example, 1 by 2 is a rational number. If you divide 1 by 2, you will get finite answer as 0.5. That's the reason it is called as terminating, because you are getting finite answer. However, if you take number 1 by 3, if you divide 1 by 3, you will get answer as 0.3333 and so on. This can be represented as 0.3 bar as well. However, you can see this is a non-terminating series and this number 3 is repeating. That's the reason it is called as non-terminating and recurring rational number. Let's take another example, 1 by 4. You will get finite answer here, that is 0.25. However, 3 by 11, you will get answer as 0.272727 and so on. You can see this 27 is repeating and this is a non-terminating series. That's why it is called as non-terminating and recurring rational numbers. Let's understand the irrational numbers now. And irrational numbers are the numbers which cannot be represented as fractions. So these numbers cannot be represented in P by Q format. These numbers are exactly opposite to the rational numbers. And these numbers are non-terminating and non-recurring. We have seen the rational numbers which were either terminating or non-terminating and recurring. However, irrational numbers are non-terminating and non-recurring. So let's take example. Square root of 2 is an irrational number. The value of square root of 2 is 1.41421 and so on. You can see this series after the decimal point is non-terminating series, and that's the reason square root of 2 you cannot represent in P by Q format, and that's the reason it is irrational number. Square root of 3 is another irrational number. So value of square root of 3 is 1.73205 and so on. You can see this series is non-terminating. However, what about square root of 4? It cannot be irrational number because it has value as 2, which is terminating. Let's take another classic example of irrational number. So pi is an irrational number. If somebody asks you what is the value of pi, never say value of pi is 22 by 7, because 22 by 7 is an approximate value of pi. The value of pi is 3.14159 and so on. So this series is non-terminating series. That's the reason pi is an irrational number. However, if somebody asks you, is 22 by 7 rational number? So your answer should be yes, it is rational. However, pi is irrational. So please make a note of this. Coming to how to represent the irrational numbers. So irrational numbers are most popularly represented by letter Q complement, which means everything outside Q. Q is a rational number. So what is not rational is irrational number. Or some places it is represented by R minus Q. R is set of real number minus rational number will give you the irrational number. Some places it is represented by letter I or letter P as well. So these all are representation of irrational number, which is a set of the numbers like square root of 2, square root of 3, square root of 5, pi. E is a Euler's number, which is also a famous irrational number. Coming to how to remember the irrational number. Just look at this word irrational. Just see the word ratio inside it. So whatever cannot be represented in form of ratio or fraction, which number cannot be represented as a ratio or fraction, is a irrational number. It is as easy as it looks. Coming to real numbers, the real numbers can be defined as union of rational numbers plus irrational numbers. So Q is a set of rational number and Q complement is set of irrational number. Or we can say any number that can be plotted on this number line is a real number. For example, we can plot this irrational number square root of 2 on this line. We can plot pi here. We can plot minus 2.5 here. We can plot 14 by 3 here. So any number which I can plot on this number line is a real number, in short to say. Now how we are going to remember the real number? As the name real says, the number that is real or that exists is real number. Or we can say this is not an imaginary number. In fact, the real number had no name before the imaginary numbers were invented. Let's understand the last number type, which is imaginary numbers. By definition, all numbers are imaginary numbers except real number. Let's take some example to understand the concept of imaginary number. If I ask you what is value of square root of 4, you'll give me answer as plus or minus 2, because 2 into 2 is 4 and minus 2 into minus 2 is also 4. However, what is the value of square root of minus 4? Let's assume the value is x. Square both sides, will get minus 4 is equal to x square. Now tell me, is it possible that square of any number is negative? No, it's not possible. So that's the reason this square root of minus 4 is called as imaginary numbers. So imaginary number is a number which when squared give you the negative result. For example, square root of minus 1, square root of minus 2, square root of minus 3, and so on, all are imaginary numbers. Now the question is, how will we find the value of imaginary numbers? So let's take some example. Let's try to find out value of square root of minus 4. Try to find out value of square root of minus 9. So square root of minus 4 I can represent as square root of 4 into square root of minus 1. Square root of minus 9 I can represent as square root of 9 into square root of minus 1. Now this will become 2 into square root of minus 1. This will become 3 into square root of minus 1. Now you can see each imaginary number can be represented in form of square root of minus 1. So what scientists did, they termed this square root of minus 1 by symbol I. So I means iota. It is called as iota. So square root of minus 4 become 2i and square root of minus 9 will become 3i. Now let's understand the basic property of this I. So I has value of square root of minus 1. Value of I square will be minus 1. Let's square both sides. Value of I cube will become minus 1 into I, that is minus I, and value of I raised to power 4 will become minus 1 into minus 1, that is plus 1. So this is the basic property of this iota. So friends, this is the basic concept of imaginary number. We will come up with the advanced concept in next videos. So friends, I hope you like our videos of the number system. If you like, please do not forget to subscribe our channel.